Okay. So, what conversion factor do I need to be able to answer this question? What fact? 12. There are 12 eggs equals 1 dozen. Yes? Okay. So, I'm going to go the chemistry route here. Factor label, unit conversion, unit analysis. I don't know what, called different things. But what am I going to put down below? Eggs or dozen? Eggs, because this is like over 1 if you wanted to do that. You got eggs down below, you have dozen above, in order that the eggs cancel out. Okay? So you have 12 eggs for 1 dozen. I'm bringing this information down here. And so you're going to say 30 times 1 divided by 1 divided by 12. Forget the ones, they're kind of placeholder. 2.5 dozen. Okay, good with that? Okay. So to make sure we're right, would we expect the answer, how many dozen, to be less than or more than, greater than 30? Okay. Obviously less than, we got the answer, bless you, but why? Why is it going to be, why would we anticipate, why would we expect that to be a smaller number, other than the fact that you're dividing?
Because there are pretty already in that dozen. Because since it's a group taken out of the 30 count, unless every egg was its own individual dozen, it couldn't be 30.
Okay, let me phrase that a little differently, but you're on the right track. Which is a bigger unit, a single egg or a dozen of eggs? A dozen of eggs. So if we're going from a smaller unit to a bigger unit, expressing the same quantity, we're going to have less of the bigger units compared to the smaller unit. Does that make sense? To express the same amount, there's going to be fewer of the big units compared to many of the small units. Okay with that? Okay. You already did that. All right. So when I pose a question, what I want you to do is I want you to think about it in your head, in your brain. If you are a verbal processor, hang on to that desire to communicate. Okay? I want a conversation inside your head. I don't want you to influence or be influenced by anybody else. You'll get that opportunity momentarily, but I want everybody to independently think. Give me a thumbs up when you have an answer to this question, and more importantly, the reason why you have an answer to that question. Talk to your neighbor.
I think there's going to be more.
Okay, what do you say? Correct answer is A, more. Why? We're going from a large unit and we're converting to a smaller unit, so there are a whole lot of little units in one big from converting from a big unit. Good with that? quick side note, if you find yourself in a neighborhood that is not conducive for conversation, you might want to move neighborhoods. Okay with that? A lot of what we're doing in this class revolves around conversations like that. Okay? So, or if you don't want to move, make it so it is conducive for conversations. Step outside of comfort zones and stuff. Okay? All right. So, I know this is a ridiculous question. No one cares how many inches are in a mile, but just for the sake of thinking through something like this, what conversions would be helpful to know other than miles to inches or inches to miles?
We do like miles to feet and feet to inches.
Sure. Do we know? Anybody have an answer for how many feet in a mile? Okay, 5,280 feet in a mile. And then most of us are able to figure out there's 12 inches in 1 foot. Okay, so what we can do, 3.1 miles. So what am I going to stick down here? 1 mile, 5,280 feet. And then go from feet to inches, 1 foot, 12 inches. The miles cancel out, feet cancels out. You're left with big number or small number. It's a big number. You're multiplying all this stuff. To be honest, I don't really care what the answer is. I mean, no one really. If you ever run a 5K, you're running 3.1 miles or 196,000 inches. Okay, good. This, however, is a more relevant question. Okay, we are very familiar with speeds measured in miles per hour. However, in physics, we like the metric system. So we're going to use not kilometers an hour, but meters per second. Okay. So what conversions, what other information could we use besides this? Like in addition to, what other things do we need to know? Factoids. Okay, that would be good. I don't know miles to meters. That would be great. Miles to kilometers. We could do that. Does anybody know what that is?
6.2 something.
Mm,
6.2.
I think that's point. That sounds right. 0.625 miles for every 1 kilometer. Okay. Actually, I know this. Check this out. There's 5 kilometers is 3.1 miles. Could do that. Doesn't. Honestly, it doesn't matter. Okay, we'll use any of those. Okay, so we're now at kilometers. Now what?
Divide by 1,000.
Okay, there are 1,000 meters in 1 kilometer. Okay, so now we've got the distance aspect nailed down. but we've got hours. I need to change that to seconds.
Oh, 60.
What?
60 seconds.
Okay. There are 60 seconds in 1 minute and 60 minutes in 1 hour. Okay. All right with that. A lot of different ways you can do this, but we'll go with that. So 65, now check this out. This is important. Miles per hour, I'm going to write it like this. You could, if you wanted to, write it like that. Okay. That's an important thing. So, miles, I'm going to convert get the distance out of the way. So, I can go miles down here, kilometers down here. I could use either one of those. I know this one's valid. 3.1 miles, 5 kilometers. You okay with that? Just using this conversion. Okay. So now, what should I stick down here? Kilometers. And up top, meters. So I have 1,000 meters for every 1 kilometer. Okay. If I were to stop right there, what would be the unit of that if I did the math there? Meters per hour. Would that be a big number or a small number? Big. If you're going 65 miles per hour, how many meters per hour is that? A whole lot more. But I don't want to stop there. I want meters per second. So I've got hours here. Do I need to put hours on top or on bottom? I need to put hours on top to cancel this out. 1 hour, 60 minutes. Okay. Same thing here. 1 minute is 60 seconds. Okay. And now, where am I at, unit-wise? Meters per second. So, what I want to do mathematically is take 65 times 5 times 1,000 divided by 3.1 divided by 60 divided by 60. Okay. And I'm going to get 29.1 meters per second. Okay. Now, here is a popular wrong way to do it. 65 times 5 times 5,000 divided by 3.1 times 60 times 60. When you do times 60 times 60, what your calculator interprets is the 60s on top. Okay? So you should do divided by 3.1 divided by divided by 60 divided by 60. Or your other option, if that just irks you, is to go divided by parentheses 3.1 times 60 times 60 in parentheses. You can do that too. Okay, just make sure you're not going times 60 times 60 without the parentheses. Beautiful question. Significant figures in this class, give me 3 or 4. Just ballpark. Okay, I'm not, you learned that in chemistry, right? We'll call that learned. Okay. Okay. So, in a practical sense, we have an intuitive feel for speeds in miles per hour. One of the beautiful things with physics is you can look at an answer and say, does that make sense? Does that match my experience in reality? Okay. In general, to convert between miles an hour and meters per second, just divide by 2. So if you've got something that's moving 20 meters per second, you can it's about 40 miles an hour. Just have a gut feel. Good with that? Okay. All right. The metric system. You've been introduced to that since junior high, right? Some of you, your teachers have made you memorize that. But it's still not in there. You know what? It's not in my head either. If you were to ask me in the middle of summer, hey Smiley, what's an attometer? I have no idea what an attometer is. Okay. We live in an age where memorization is not as important as it was definitely a century ago, and even definitely like several decades ago. We don't need to be walking encyclopedias anymore. If you have a smartphone, you're a walking encyclopedia. Hey Google, what's an attometer? Okay. Sadly, our school system still rewards people who memorize well. That's how you got to this point here. You were good memorizers, right? Okay. That skill does not, I mean, there are some things you need to memorize, like you need to memorize that you need to drive on the right hand side of the road. That's just good to know. Okay. I'm not saying memory is like worthless, but like you don't, I will give you this chart. You just need to know how to use it. Okay. One of the things that makes this class hard is that I don't make you memorize stuff. I make you apply the information I give to you, which is a whole new skill compared to what you have been taught that is important throughout your education. Okay? So, here's how we do this. So, millicenti, kilo, my guess is these 3 you have memorized just because you've been exposed to it enough. Just like, there's 12 eggs in a dozen. No one ever told you to memorize that. You just learned it because you got exposed, okay? So these are prefixes. These can be attached to any type of measurement. So like milligrams, could be millimeters, it could be milliliters. Any type of measurement can be associated with milli as a prefix. Okay. What this means is there is 1 times 10 to the negative third milligrams for every 1. Nope. Bad teaching. 3 times 10 to the, right, 1 times 10 to the negative 3 grams for every 1 milligram. This times the base unit gives you your prefix whatever. Okay. If we had 1 times 10 to the third meters, that's equal to 1 kilometer. That's how you use this chart. Okay. So looking at this, 57 microliters. I want to convert to liters. Is that going to be, your answer going to be bigger or smaller than 57? Think. Thumbs up when you have an answer. Tell your neighbor and tell them why.
Micro. Base unit. You compare. Great. So my final answer is B.
Correct answer is? Correct answer is B, less than. Okay? You scroll through here looking for that funky symbol, like, oh, there it is, micro. Okay? We've got enough technology around us. Does milli, micro, nano, pico, do those sound like big things or small things? Small things. Okay? So we're going from a small thing to the base unit, which is larger. So we're going to end up with a smaller number of a bigger unit. Okay, so we anticipate the answer to be smaller. Okay, here's how to do that correctly. So we are looking at this, and we know that 1 times 10 to the negative 6th liters is equal to 1 microliter. That's how we use that chart. And so we go 57 microliters times, most people have no problem with this, putting microliters here and liters up here. So we have 1 times 10 to the negative 6 liters, 1 microliter. So when we multiply this out, what you get is 5.7 times 10 to the negative 5th liters. Does that correspond with what we were anticipating? Is that number bigger or smaller than 57? Smaller. Here is, okay, statistically speaking, taught this for lots of years. I've got thousands of students' data to verify this. A fourth of you are going to miss this problem on a test. Okay? And I'm trying really hard to prevent you from being in that 1/4. Okay? Here's the wrong answer that 25% of you will put. You'll do this great. That's not a problem. But what you'll do is you'll do the chart wrong. You'll go, okay, 1 times 10 to the negative 6 microliters is every 1 liter. And you plug that in your calculator, and you're like 5.7 times 10 to the 7th liters. And then you walk away. But if you asked yourself that question even before you started picking up your calculator, you would get to your calculator and go, wait a minute. That number is way bigger than 57. Something's got to be wrong here. And if you don't do that, you're gonna miss it. Okay? But I'm trying to teach you, don't just blindly trust your calculator. Does that make sense? Ask yourself that question. Okay, last problem. So if you have squared meters, I want to convert to centimeters. What you're going to do, recognize that this is 3 meters times meters. That's what meters squared means. So you're going to convert, sorry, that's a meter times a meter, not millimeters. 1 meter is 100 centimeters. That takes care of one of those. You do that twice to get squared centimeters. So 3 times 100 times 100. Good there? Okay. You have a worksheet that's due tomorrow. It's on Canvas. It says it's due at 11:59 tomorrow. It's due when you walk in here tomorrow. Okay. You can print out the worksheet. You can open up the worksheet on Canvas and then do all your work on a notebook piece of paper. You can do all your homework in a notebook. Does not matter to me. You will never turn in your homework. But what I will do is I will go around and check for completion. Now, inevitably, there will be a question in physics at some point where you don't know how to do. At that point in time, what I require you to do is write a specific question or statement addressing what it is that prevented you from finishing the problem. Okay? Don't ask me, how do you do this problem? Or I don't understand, or a question mark. Okay, that's worthless. Give me something specific, showing me that you struggled. Like, hey, I've got 65 miles per hour. What do I do? How do I do the unit in the denominator? I don't know. That doesn't make sense to me. That's a good question. Okay. What that gives me is evidence for effort. Because what about the other kid who's like, oh, I got physics next hour. Oh, don't know how to do that one. Question mark. How do you do this question? And like, I need evidence to earn effort points. Does that make sense? Okay, so right there on your paper, give me a good question, and that'll count. Okay. The day it's due, I will give you the answer key. You'll look through that. Hopefully that be able to answer those questions. Okay. So you got that worksheet. It's on Canvas, due tomorrow. Sound good?
Do we get the worksheet?
You can print the worksheet at home. You can print the worksheet here. However you want to do it. Or you can just open it up and look at it and do it on a notebook piece of paper. You have options. Okay.